presentation on LabVIEW versus Python. Moses Ramon was presenting on, hey, great, how do we do this? And thought it might be a fairly complimentary presentation. I think it's a similar topic, but addressed in a slightly different way. But very quickly, I did throw together a quick about me slide because everyone else had one, so I threw this together. I've been at NI 7 odd years now. If you hadn't guessed, I work for NI by the part where I'm wearing a stack of branded NI Amazon stuff. I work as one of the field application engineers across UK defence and government. So I essentially work for us as like a technical solution architect and like capability figure outer, and then doing a lot of requirements capture and figure out what does NI need to build out for its roadmap to help support the UK as a whole. And I've been at CLA since 2021. So I'm roughly just going to look at, great, why LabVIEW, why Python, how do you actually use them together, and why you'd actually care about doing that. So I'll start off by just saying there's a stack of just software languages that exist in the world. Purposely, LabVIEW Python are not on this list, just reference if anyone chats me for it. But I think if anyone turned around and said that they're like a firmware engineer, most people would assume they're doing something in C. If someone told you at like a party that, hey, great, I'm like a web front end dev, I make like websites look pretty, you probably assume they're like JavaScript or something similar. And my general point of this slide is there is like a specialization of a lot of languages that is useful for those languages. And then you have the more general purpose languages that abstract things out that do pretty much everything fairly well, but nothing that's like too deep in that and then like a vertical space that does it particularly well. But then largely Ramon mentioned he's the only LabVIEW dev on his team. And so, yeah, if you were on holiday or like you were off sick or something happened in some capacity, any sort of LabVIEW dev on your side like just stops entirely and no one knows what's going on. So the point of like, great, you have languages that are specialized for different things. Equally, your team should probably figure out what language you're using based on what you actually know. And for most of us here, I think most of us are in like the T&E space in some form, where you have like general software pieces that if someone came and said, great, I'm a software engineer, you're assuming they're doing like API, database, cloud calls. If someone said, hey, great, I work in like the test domain, you're dealing with like messy physical connections. You've got a load of devices that are from different vendors. You might have like a PXI over there, you've got a PLC there, you've got like an SMA over there. You've got a load of different devices that you're interacting with in the physical world that have different vendors and probably different communication buses or different communication protocols. And maybe some of it's safety critical. Like you want some to monitor like, hey, great, what's the flow rate over here? And you kind of want to make sure monitoring this doesn't stop any of this. And equally, if you're activating like a DMM switch, you're still keeping like an eye on everything that's actually safety critical on this end. So there's some level of just like test software has very specific requirements for being able to interact with multiple devices, being responsive, UI, deterministic, safe, all those pieces, which not surprisingly I'll get to, but LabVIEW does most of those things. So there's a stack of stuff that you can look at for like where you actually need for various software if you're dealing with hardware. So connectivity, deterministic I/O, orchestration, control flow, analysis, deduction logic, data management, traceability, deployment, sustainment, and so on. If you're looking at like connectivity, deterministic I/O, LabVIEW's got a stack of drivers that exist for things. Python does as well. And Python might have some for some instruments, not for others. Analysis pieces, LabVIEW, we have like all the signal processing toolkits. If you're looking at doing like, so I do a lot of work with like RF stuff. You look like new radio, Wi-Fi, like Wi-Fi 8 stuff. Those toolkits exist. If you're looking at Wi-Fi 8 past what the NI toolkits enable during LabVIEW, you're kind of stuffed, to be honest. And you do need to look at, hey, great, here's an open source ecosystem somewhere. Same goes for like deployment, sustainment. I'll just go to the next slide because I think this also talks about it. But for Python being like highly portable in this case, you can get Python to run on pretty much anything. Like if you have like an ARM processor, there's a Python deployment for that. You can just carry it around as a lightweight piece and basically put it to like any piece of hardware. And there's a giant community of people that do that and publish a load of open source packages and libraries that you can harvest. And this last one of Python's free. It is kind of handy. Like I come in at some, I work at NI. I get LabVIEW for free. Everyone else in this room is in loop. Like you might get it for like a subsidized rate of some kind, but you are paying for an actual LabVIEW license, and there is value in just having, hey, great, this is like Python is free, and just you can distribute it however you want. Separate on the LabVIEW side, there is really easy hardware integration. The RT and FPGA application development piece, I think, is something that's really undersold. Of if you're a LabVIEW programmer and someone turns around to you and says, "Hey, great, we have this FPGA like deployment that we want to do," the programming like workflow is the same between LabVIEW and LabFPGA. Sure, there's a little bit of like paradigm to figure out and learn. It's like, great, you've got to understand how single cycle time loops work, how does pipelining work, but you're in the same development environment. You're no longer just saying, great, I need to understand how the hell to make HCL code work or understand like Verilog syntax. Same for like real-time development. Built-in multi-threading support, easy GUI stuff. I promise this isn't all slides. I do have exciting demos at the end of this. I should have started with that. I do have demos. I've got demos, maybe not exciting. LabVIEW side, great. We're all LabVIEW users here. It's a user group, so I'm not going to spend too much detail on this. All the stuff for that. I do want to highlight, has anyone ever looked at what LabVIEW does for like LLVM, like compilation down to CPU instructions before, and how it optimizes things? Yeah, like
there's some white papers that explain it all. It's quite interesting. Yeah.
Yes, yeah, genuinely. If people don't know it, I would encourage like
good bedtime reading.
Yeah, go nerd out on it a bit. But LabVIEW does a lot of stuff with checking, great, what can be parallelized, what can't be parallelized, and what's unreachable code, and removing it from execution. Separately, if anyone's ever had to like debug like LabVIEW like clumps or heap peaks, and like if you're familiar with NED, firstly, I'm sorry. But secondly, like all the clumping stuff that LabVIEW does to actually optimize, great, how does an application work? Is actually kind of useful. And then all the stuff for great, how it does that. We'll skip past that. Other than that, we all know data dependency can run in parallel in LabVIEW. Python wise, and this is probably where I'm going to spend a bit more time just for those that aren't as familiar with Python. So it is an interpreted language, so it's a fairly high level abstracted language that's cross-platform, but mostly this of like the large ecosystem of IP is, well, okay, there's two reasons I think people use Python. One is it's got a large ecosystem of IP, and that in itself builds more people using it, and that's a larger ecosystem of using it. And part of that is because it's free and open source, and anyone can just download it and use it. The other part, it's just, yeah, it's free. Just get it. Sorry. So it's really easy to just like stack through that and just stack up a load of libraries. Quick cheeky plug of Python does have native support for most NI hardware, if not everything. You can call like the Rio FPGA stuff once you programmed it in Python. But besides that, we've got two languages. One for LabVIEW, which we all know and love. We're all LabVIEW programmers, and then Python, as everyone learns it in university nowadays. So if anyone's currently hiring new grads, everyone's probably got Python on their CV in some capacity. I guess I'm looking for anyone that's a fresh grad. Python. Did you do it at uni? Did you just touch on it?
Touched on.
Did you touch on LabVIEW at all?
No.
Did you know it existed before you graduated?
He's an apprentice.
Did you know it existed before you became an apprentice? Exactly. Go, I'll take it. I'm just about. I've got demos, so I'm not going to spend too long on this stuff, but there are just Python nodes for calling Python in LabVIEW, and separately you can call LabVIEW from Python. There's a bidirectional like integration for this, and all the stuff. I think Rowan had this exact slide. Of we put in the Python node 2018 because we got the feedback of everyone knows Python. Please God, give us something that we hire new grads and they know one language. We need to be able to work with them. We want to put them to work. Great, they develop code in Python that integrates into your LabVIEW ecosystem while they're learning LabVIEW or while they're just stuck on Python if they want to be. We spent a while since just updating that Python support, and then 2024 we put in virtual environments, which Ramon spoke about. I want to highlight virtual environments, super useful. I think I've got a slide on it in a second. For anyone that needs to know how to pass like So all the like the basic data structures like numerics, booleans, text, and so on are just a one-to-one map between Python LabVIEW if you use the Python node. If you're using like lists or tuples or anything like that, or dictionaries, you can convert between them if you have like named data types in LabVIEW. There's a KB that exists that I found out because I was Googling in preparation for this. I found out I wrote this KB 4 years ago. Don't remember what I put in it. Did find out there used to be code attached to it and someone removed it at some point, but there are still like snippets you can grab. But there is a detailed like article on Great if you're using particular like complex structures, how to make that bidirectional communication happen. And then all the support for different versions. This is technically wrong in that my Python install is 3.14, and all my examples that I'm going to show today in demos are 3.14. They run fine on my 2025 Q3 install. So this should expand left. I think it's officially tested in release versions, but it works. Cool. Very quickly touching on virtual environments. The whole idea behind Python introducing virtual environments, so you could segregate out different workspaces for different versions, different drivers. So Steve gave a presentation earlier on like different virtual machines for different LabVIEW versions and different LabVIEW driver stacks. Virtual environments are that, but built within Python. It's essentially building up a great user virtual machine with specific application and driver support for it. So if you had someone building out all your like duck control in a Python version, or your data analysis in a different version, your reporting in a different version for different teams talking to each other, you can essentially say, great, I'm going to wrap this up on driver versions. You can essentially say, great, I'm going to wrap this up as a particular like deployment of that environment and say, great, this is going to run this Python version with these packages, that Python version of that package, that Python version of that package. And essentially wrap up, here's like a nice deployment piece, essentially like similar to a virtual machine, like deploying like a Docker container of here's a nice self-contained application space that only runs this code because we're worried about backwards compatibility or something in there. We can call that in LabVIEW nicely, which is really nice. There is a function that is just open virtual environment. So very quickly, I'll demo this. So I'm not going to spend time on this. I'm not going to demo the integration with test stand, but for reference, any test stand devs, there is just a Python set of steps in test stand. So you can just call Python functions in test stand. And for those of you that are like various end users or DNM users, SystemLink users, Python can script these as well, just for reference. Cool. I ignore the really bad AI generated. I stole the next any slide that has these on. I stole from marketing. I promise they're not mine. I hate them, but it'll do for now.
You lying? I saw him making them.
Cool. LabVIEW calling Python is great. Here's a node that does this. You can pass through Python classes or parameters, and let me just, rather than talk about this, let me stop sharing my screen real quick. And where am I? Cool. Hopefully everyone's currently looking at my LabVIEW. So there's a couple of pieces of this, and I'm just going to walk through what an example VI of this does, or a couple of example VIs of this. So who here has played around with the Vision toolkit that NI publishes and largely maintains nowadays? This is a VI that's going to combine some of the NI Vision IMAX stuff with some Python OpenCV stuff. So hopefully you can see roughly where I'm pointing, but we're going to open up just like an IMAX reference to an image. In this case, it's going to be this lovely coin image, which I can go pull up and figure out where I am. We're going to pull up this image of a stack of coins and put it into a buffer. We're going to open up a virtual environment to my Python, and I'll go through how we make that if we need to. We're going to make an analyzer in Python. We're going to essentially grab the reference to this image and say, great, read that file, and convert it into something that NumPy wants to read. And then we're going to call the Python function analyze image, pull out features, and then we're going to overlay it using using IMAX stuff and just say, great, go make an overlay on this. So the like native LabVIEW parts of this are the nice bottom parts of create an image buffer, load an image into that buffer, read that, pull something from Python, and then create an overlay on that image. The Python part of this is this lovely analysis bit, which is a Python script that's going to call in OpenCV like blob analysis, which has a lovely, lovely documentation piece, which I can go. Here we go. I like, great. What is a blob? There's a stack of different ways to filter blobs between area, threshold, circularity, inertia, and convexity. In this case, we're just going to look for circles. Nothing too complex. But in this case, great. Here's the parameters that we're looking for. Filter by color as well, by area. Here's the area. Here's the thresholds we're looking at. And then we're going to shove out, great. Where are the blobs in the image? Give me the key points to this, and give me the actual coordinates of where are the things that you think are a blob. And then we're going to pull that data out, and that's what gets overlaid. So in theory, what happens if I run this, is I should be able to run this. It should load an image. And then we pull out, hey, great, here's a stack of blobs. And I don't know if you probably can see it on the screen, but it has actually overlaid a load of like red circles around things that it thinks are blobs. So that's combining, hey, great, we've got some vision coming from LabVIEW, and then calling into the OpenCV, like open source, like vision toolkit in Python, pulling that out and saying, great, here's an analysis, and then overlaying it back onto the NI vision piece. We can do that, and this is the part where this is going to depend on how good the lighting is in here. When I go pull this up, we can do a very similar thing, except rather than doing it on an image, we could say, hey, great, create a buffer, connect to a camera, and do the same thing of we're essentially just going to grab snapshots of my camera and then run into the same piece of we're going to call a Python code that calls on the same analyze image, pull out, great, where do I think the blobs are, and try to overlay it. And this might not work just for the part of it's going through my webcam if I actually enable this. Well, let me run this. Look, it should get. Oh, why has Teams got my camera? I released my camera from Teams. There we go. And then if I pull out and think, for some reason, it thinks there's a stack of coins. I think you can see the overlay going on that sign. Don't get out of the way. It's a technically, hey, great, there's a load of circles on that sign and a bit of the fire extinguisher that are coins. Because all we're really doing is, hey, great, where's the area and where's the color? But if I like block it all with, hopefully not my crutch, I just hold this up and let's see if it actually figures out, is this a coin? Or if not, the lighting might be too bad. Come on.
Do you want someone to try and talk?
Yeah, let me just grab my flashlight with my other hand, see if I can get it to detect. See, I flash that on that. It's occasionally spotting something,
Yeah.
very occasionally. The lighting's not great, and it's also not a particularly like advanced search of what the actual like analyze image is doing. But in like, did it find? Hey, yes, okay, detected my LabVIEW badge as something. Which I guess makes sense. It's looking at a color difference in an area. So yeah, it's figured out, hey, great, here's a big color difference on my chest. But overlay. But functionally, this is great. We're creating a camera reference through LabVIEW iMac and all the vision drivers, and then just using Python to pull out, hey, great, here's some like open source image toolkits bit. We can go further than just doing the like image stuff. And I'm gonna steal your LCD for a moment. And if I go pull up an example, I think most people probably know the like Dynamics analog in, analog output examples, probably off by heart. So this is one of the Dynamics just like analog output, continuous output examples, exactly the same as you'd expect, except at the very start, it's great, we're opening up a Python session. And then rather than generating like using the LabVIEW to generate just like a normal sine wave, I have a lovely function that's called generate sine wave and noise in Python. I'm just going to use that to generate my actual output. So if I go target, what channel do I need? Output, yeah, output 1. So I go generate that at some level of noise frequency and sine frequency. Open run. Yeah, okay. So we're generating a stack of data. And similarly on my input, I can go ahead and run this. And this is exactly the same like Decamix input example that you're all used to, except that what we're actually doing is we're calling a Python example that is called remove noise. And it's going to take in like a fairly noisy signal and filter it out. Let me reduce this back down to 1 because my laptop's dying from doing this. So here's my actual acquired data of a fairly noisy signal. After going through the Python node, it actually removes the noise source. Great, here's my noise source, and there's an FFT that I'm pulling out as well from Python. So let me go back to the actual code side of this. So Decamix reading from this, plotting it on, hey, great, here's the graph where we're taking out originally, then taking out, great, all the Y values of it, passing it to the Python function, and then we're getting out, great, here's the filtered values, here's the FFT. And then essentially just ignore this, and then just closing all of it. So this is Python acting on essentially acquired data to pull out, hey, great, here's NumPy doing some noise reduction. This is something that is actually like a functional use case that is why you'd actually look at kind of integrating the two. Like you could do this using LabVIEW toolkits, like quite easily. Like we have signal processing kits that can remove noise and do FFTs. But you can imagine if this was something more complex or something more custom, then it would actually be quite useful to be able to pull this out from someone else that's developed in Python. In this case, quite literally just like open source example that was just how do you remove noise from a shaky sine wave and like reformat it. If that example just exists in Python, I just pulled that out and we sucked it into here. But that is just great, essentially calling up, in this case, open up a session, call the Python node, specify what function you want, and all the inputs into this just auto-populate based on the function, and you wire it in and say, great, here's what I'm reading out from this and what I'm expecting to do. We're all good on calling Python from LabVIEW for now? All happy with that? Thanks for letting me see CDEC. Let me put it back here so I'm not in the way of the screen again. Similarly, Python calling LabVIEW. So if anyone's done any work through like ActiveX or the VI server stuff of calling probably VIs from other VIs for the most part of, you like if you're popping up different VIs and showing front panels or not, all of these functions are available through the Python API. You can do the exact same thing of this. If you can call a VI, you can pop up with the front panel or not if you want to. You can set control values. You can run it and then say, great, do you want to wait till you're done and run it like as a asynchronous process, or do you just want to run it as a one shot and leave it? And there's actually two Python like API calls for it. There's vi.call, which essentially works without a connector pane, but you essentially have to specify out here's all the like control values that exist on the front panel without a connector pane, and it's a very rough of just run it and go, so you can actually see it's just correctly shows like vi.call, or there is vi.call 2, which gives you options for running that VI. Do you want to like pop open the front panel or leave it closed? And what values of the connector pane do you want to populate, and what values do you want to leave as default? So I should actually just be able to run this as well. Where am I? Let's pull this up. Bear with. I'll come back to this in a moment when my brain's working. but essentially the ability to dictate out, great, here's the connector pane values to call in, here's the LabVIEW BI. So if you have someone that's developing in LabVIEW, but your main like system architecture is in Python, for instance, if you're the only LabVIEW dev, people could develop stuff in Python, you can develop something in LabVIEW, they can still call in your VIs, and whether that's load it in, even if it's like as a front panel, and load it in for user interaction and then call it on the back end with things. Essentially, you get all that like API to be able to do this, and you can actually do this for the LabVIEW runtime engine as well. So if you built a LabVIEW executable, you can actually expose that to the Python API as well. So you can inject code from a Python instance into a LabVIEW executable on the runtime engine. But you have to enable, there's a tick box to enable the ActiveX server when you're building the executable. Works for LabVIEW as well, for reference. If you built a LabVIEW executable, you can call that in LabVIEW and inject code into it. But if you wanted to build out, hey, great, here's part of your team that develops in LabVIEW, part of your team that develops out in Python, and shove that across, then that works. The third and kind of rogue entrance is, I don't know if anyone here has been exploring like remote calls, like gRPC as a technology. I'm not going to demo this. I'm just going to talk about it. Some people are smiling and some people are giving me blank faces. gRPC is Google's remote procedure call. It's essentially like a publish subscribe streaming architecture where you make a server that reacts to requests and then streams data back when you actually make those requests. That exists for multiple languages. It's meant to be a language agnostic piece so that you can essentially say, great, I want my application over here to do this. And any language that has gRPC support, which is most of them, essentially takes in a proto file of this is what this application will respond to, and that application over here essentially sends a request and says, great, go do this and give me the data. So it could be, great, go do this, give me DMM readings. It could be, hey, just go kick off this piece and just give me a response and go stream data back. But that exists across most languages, but equally exists within LabVIEW. So there is just a gRPC toolkit that just generates all like the actual proto file and everything that describes, hey, great, here's the server of the application. Python also has one to generate out, here's the server and application. So you can make that connection between a server and an application real easy between the two languages. I'm coming to the end of my presentation, by the way, so get ready with questions. So for reference, so Python, huge, like number one, like most used language in the world. So you kind of have to consider it. Like everyone coming out of university, or most people coming out of university have touched Python in some capacity. But even if they haven't, the amount of free content that exists for just learning Python is outrageous. Like you could Google, great, how do I do this in Python? And you can pretty much guarantee there's going to be about 5 YouTube tutorials on doing the exact thing that you're trying to do, and several blog posts. And then if not, you could probably just like AI vibe code your way through it. LabVIEW, on the other hand, super strong for like hardware interaction, actually integrating with like real physical pieces and doing all the parallelism that we love about LabVIEW and everything else. But generally, like Python is like a general purpose tool. LabVIEW is a fairly specialized tool for what we do. Like largely, just to check, anyone in this room that uses LabVIEW that doesn't do it to integrate with hardware? Cool. If you had to do advanced signal processing without any hardware interaction whatsoever, who would start with LabVIEW? Yeah. I probably would as well, but that's because I'm not confident in like MATLAB and stuff. If I was just gonna give a random person, like a random team, like, hey, great, use any language you want, assuming you're an expert in all of them, do some advanced signal processing, I somewhat assume they'd probably pull out like Python or MATLAB rather than LabVIEW. Like LabVIEW's good at signal processing. It's not the best. There's a tool for every job, right? There's a stack of resource examples and more if you have a Google round of how to actually do this, including most of the code that I pulled up is just published on Git for reference. But you can just pull that in, and if you, whatever reason you have for like needing to use Python, whether that's skill set of teams, if you're the only LabVIEW dev, or if you're just hiring people and you need to get them like up and running quickly, they probably have Python experience. Or whether it's just to make use of like Python's giant libraries, it is handy to be able to have bidirectional communication with it. And I think that's officially my last slide. Questions? Oh.
What's the latency like when you call a Python function or when you call a LabVIEW function in Python?
Good question. I don't know. I've not actually characterized it. I've never done anything that required deterministic control between the two, mostly because Python as a language isn't that performant. I remember running some tests of like LabVIEW versus C versus Python, just like how quickly can you run through these the same things. C was best, LabVIEW was only marginally behind, and Python was considerably worse just in executing things because it's a higher abstraction layer. It has to go through quite a lot of stuff to actually get down to like CPU instruction layer. So I probably wouldn't be trying to do it for deterministic pieces. I'd probably, if you had actual like latency requirements that were somewhat stringent, I'd probably stick with a performant language, something like lower level, like LabVIEW or C or C++, whatever you're doing, and then leave like post-processing or like less real-time pieces to Python. That's a good question. I've not actually characterized it.
Yeah.
Go find out if you want. It's surprisingly easy to set these up. It is quite literally. I mean, I'll flick back to my block diagram real quick. I'll even go to show one of these tabs somewhere. Just go pull up.
So when you're calling a LabVIEW function in Python, does it have to boot up LabVIEW as well for it to?
It does, yeah.
All right.
Yeah, it does boot up LabVIEW. For references, like we published a load of lip shipping examples for this, including the simplest version of here's how you add numbers through a Python node, which is a crazy thing to actually do because LabVIEW does that more performantly. But we publish a lot of shipping examples, which is great. Here is opening up a Python session, calling add, and giving the like A, B, and pushing out A plus B. There we go. Okay, I don't even have a 3.14 version. But regardless, like we publish a lot of examples on how to use the Python node that get progressively more complex. So you do eventually end up in like, great, here's using like a NumPy to like matrix multiplication, which again is something LabVIEW can do, but is actually getting to more of what Python's better at doing. And then you end up with, yeah, great, how do we actually like remove the noise from signals, which is what I was doing earlier, just with real hardware rather than calling through this. So just a reference of, if you did want to try characterizing out LabVIEW in Python, there's a bunch of examples that do that. You wouldn't even have to make anything new, just put in a timer and figure out how quickly that is. Anything else from anyone in the room or anyone online?
I guess this isn't really a question, but more of a statement. But I guess with the image processing stuff, when you use the LabVIEW functions, half the functions you can use for free, half of them you have to have a paid license or deployment license. So I guess can we now use the free stuff for the actual storing of the image and then outsource the bits that we normally pay? So for us, it's not an issue. It's when we deploy it to a customer system because you have to then get
you got to get runtime deployment license for acquisition software. Yeah, you could very much do that. Yeah, I'm not saying that. Rinse it. Do it. Rinse us. Yeah.
But sometimes
it's a real thing.
Sometimes
it genuinely is.
licenses of barrier.
Yeah, especially when you're like scaling up or you don't know how to do it and you're actually deploying.
Yeah, so we've got the customer and they make production units that have that make use of the Vision Toolkit, and they have to have a paid deployment for every single one, and it increases the cost of their machine this week.
Yeah, genuine alternative would be like look to Python, look to great. How does Python deal with that? Because I'll be honest, like OpenCV Python Toolkit probably just deals with that.
Yeah,
already.
And we're detecting circles. So
yeah, in that case, there's examples that do it online.
Yeah,
but literally
some of the functions are paid for functions. Some, some of them are free. Yeah,
a genuine use case of use it to get rid of runtime licenses for VDM or VS. I'd probably do how to.
I've got a question, Nick. For that example, the detecting coins, detecting circles, if you were to do that purely in LabVIEW or purely in Python, like how much more difficult would that be, or how much additional time would that
I mean, for me personally, I'd much prefer doing that in LabVIEW because I'm a LabVIEW dev, and honestly, the vision assistant that we publish is actually pretty damn good. So actually putting in like it's an interactive way of doing like the vision development piece.
What about someone that's like the average engineer at both?
If you could use a vision assistant, I'd probably say vision assistant. If you couldn't, you could probably Google like Python OpenCV like circle detection example, and it probably exists. I mean, that's my Python OpenCV circle detection. All right, let's go. Hey, here you go. Here's a Python example that does exactly that. It's like to me, this is why Python's useful. There's a massive user base, which ironically then grows its user base to be bigger because everyone's like, oh, everyone's using it, I'll just use it. But you could just grab this and from a Google search and just use it. Validate it that it works, but just use that if you want. So just Google it. Yeah. If you're doing something more custom, I'd probably go through like the Vision Assistant and use it if you can get the licenses. Oh, just Google it in Python. I can see John typing something that looked like it was licensing info. Thanks, John.
Is the vision assistant, is it in the form of a ExpressVI?
The Vision Assistant, there is a separate executable you can call to get the Vision Assistant.
Yeah.
I don't have it on my installed on my app.
So it's exported to LabVIEW though. There's like an export.
Oh, there's
Yeah.
LabVIEW.
Yeah, it's essentially like an interactive, like
So you can build the code from.
yeah, and then it's export to LabVIEw. And it doesn't make it's not the prettiest of code, but it's
Yeah.
functional code.
Yeah.
And then if you want to make it pretty, you can go through and edit it.
It's pretty good.
I was just thinking from if it wasn't on the ExpressVI thing. I remember when a long time ago, first started working with DACMX, I was trying to learn the functions on there. And we used to use ExpressVIs, and you can right click and turn them into
Code.
into code and then take a look at how it's actually done.
Nowadays, I'd probably just recommend, if anyone's doing that, I'd probably say to go open up the DACMX examples
Yeah.
and pull going to the example find and go, wait a minute.
Yeah.
Same for just doing both things in like in the modular instruments portfolio if you're on PXI as well. If there's no other questions.